In this video, we study the 68, 95, 99.7 rule. The data shown in the table below shows the scores on a math placement exam given at Dixon College in 1992. I'm going to first open the data set in StatCrunch to create a histogram and to find the mean and the standard deviation. To create the histogram, go to Graph, Histogram, select the placement exam scores, and press Compute. As you can see, the distribution of placement exam scores is approximately symmetric and bell-shaped. To find the mean and the standard deviation, go to Stat, Summary Stats, Columns. Select the placement exam score variable, hold down the Control button on the keyboard, and select the sample size, mean, and standard deviation, and then press Compute. So you can see that we have 213 scores in this particular data set. The mean is about 10.22, and the standard deviation is 3.85. So now we're in a position to actually work this example. In Part A, we're asked to determine the percentage of scores that are within one standard deviation of the mean. This means that I should take the mean of 10.22 and subtract the standard deviation of 3.85, and this gives me 6.37. And then I should take the mean of 10.22 and add 3.85, and this gives me 14.07. So the interval that represents being within one standard deviation of the mean is from 6.37 to 14.07. So this would include all the scores from 7 through 14 shown in purple. If I count up the number of scores, I will see that there are 146, which means I have 146 divided by 213, or approximately 68% of the scores lie within one standard deviation of the mean. In Part B, I'm going to repeat this process, except I'm going to find the percentage of scores within two standard deviations of the mean. So I'm going to take 10.22 and subtract 2 times 3.85, and this is 2.52. And then take 10.22 plus 2 times 3.85, and this gives me 17.92. So this means that I'm looking for all the scores that are between 2.52 and 17.92. In terms of our placement exam scores, this would include all the scores from 3 through 17, again shown in purple. I can calculate the percentage of those scores. So if I count up the number of scores, I would find that there are 202 scores in this range. If I divide by the total of 213, I find that approximately 95% of the scores are within two standard deviations of the mean. Repeat this process one more time and find the percentage of the scores within 3 standard deviations of the mean. Take 10.22 and subtract 3 times 3.85 to obtain negative 1.33, and 10.22 plus 3 times 3.85 to obtain 21.77. As you can see, all of the scores are within this interval. The smallest score that we actually have in the data set is 1. The highest score is 19. So all of the scores fall between negative 1.33 and 21.77. So I could find the percentage, 213 divided by 213, and this would be 100%. Now, in general, you wouldn't expect 100% of the data to fall within 3 standard deviations of the mean, and the true percentage is about 99.7%. So this leads to the principle then called the 68, 95, 99.7 rule. The 68, 95, 99.7 rule states that about 68% of the data falls within one standard deviation of the mean, 95% of the data falls within two standard deviations of the mean, and nearly all of the data, 99.7% of the data, falls within three standard deviations of the mean, as you can see illustrated in the diagram.